Hi everyone, and thanks for joining us in the latest CHEMCAD webinar, How and Why REFPROP Elevates CHEMCAD Process Simulation. My name is Noelle Garza. I'm a technical specialist here with the CHEMCAD team, so I'm excited to talk to you today about REFPROP. And if you're wondering why we're talking to you about REFPROP and CHEMCAD, it's because this is the latest feature available in the new version of CHEMCAD. That's CHEMCAD NXT 1.2.0. And so check your emails for download information when that comes available to you. It should be available this week. And if you're using CHEMCAD as the web application, you don't have to download or install anything. It's just once the latest version of CHEMCAD is updated and loaded into that AWS virtual machine, you'll get access to it the next time you log in. So let's talk about what we're going to go over in this webinar. There's a wide audience that's watching this, and I don't know how familiar everyone is with REFPROP, so I'm going to just start with a little bit of the background information and the value of REFPROP before I go into what everybody's most interested in, and that is what are the changes to the CHEMCAD interface, what does it look like, how do I use it. So I'll give you a little demonstration of that and some example applications before wrapping things up and talking about key takeaways and next steps for everyone. So a little bit of background, because the origins of REFPROP actually date back to the late 1980s. And so chlorofluorocarbon refrigerants were pretty common at the time, but they were found to be damaging to the environment and damaging to the ozone layer. So there was some interest in looking at new refrigerant mixtures, and they needed industry was searching for accurate thermophysical properties to look at these new refrigerant mixtures. So the U.S. National Institute of Standards and Technology, or NIST, they answered that challenge with REFPROP. So it originally stood for refrigerant properties, but over time, REFPROP expanded beyond refrigerant properties and became an industry standard for many industrial significant fluids like cryogens, hydrocarbons, lubricants, glycols, and so NIST wanted to keep the acronym REFPROP for these expanded applications, and so now it's just known as the Reference Fluid Thermodynamic and Transport Property Calculator. And the little bit of background I'm giving you here is important because it's the standard for refrigerant property calculations, and so you'll hear me mention a bit more about refrigerant properties in this webinar, and so it's just interesting to note that that's what it was designed and developed for. Another thing you might have noticed me saying a lot of is that this is a property calculator rather than saying database, and that's because instead of just collecting and distributing loads of experimental data, they're using powerful predictive models that can simulate very accurate fluid behavior across a wide range of conditions. So it's not just a database, it's actually technically a standalone property calculator. And so you can actually it has its own user interface, so you can get a license through NIST if you want to use it as a standalone property calculator, but you don't have to do that if you're a CHEMCAD user. The value here is that REFPROP is not a process simulator like CHEMCAD. It's a property calculator. So we're bringing their accurate property calculations into the CHEMCAD interface, and then you can use CHEMCAD as a process simulator, and you just have access to that REFPROP library. So that's why we're saying we're integrating REFPROP's calculation library within the CHEMCAD interface. So there's no need for extra licensing or installation for CHEMCAD users. And so you might be thinking, wait, doesn't CHEMCAD already calculate physical properties? So yes, CHEMCAD has a long list of thermo models available and a database of over 2,500 components. So traditionally, you input a fluid composition and say temperature and pressure, and so you can calculate fluid properties like density. What is the value in adding RefProp? And that's a great question. I'm glad you're thinking about that, because thermophysical property calculation is a tricky thing. Unfortunately, there is not a universal model that fits all components under all scenarios, and we often end up having to choose from different sources, different models, data, whatever data is available to get the best prediction. So in this case, RefProp has really become an industry standard for physical property calculations. It uses powerful models, and so this is being offered in addition to what is already in the CHEMCAD library, and it's up to the user to decide when RefProp has a really good application to your processes, or if it's not necessarily a good fit, and we'll talk a little bit about that in a minute. But in some cases, RefProp has extremely high precision, especially for pure chemicals, gas, liquids in the supercritical region. It can predict vapor-liquid equilibrium very well and gas blends very well. And of course, RefProp was designed to handle refrigerant property calculations, so it's the industry standard for refrigerant blends as well. And so this RefProp is now integrated into CHEMCAD just to expand the capabilities for our users in accurate fluid property calculations. So some things that you might want to consider when you want to know whether RefProp is a good fit. RefProp is not a good fit for solids. It just wasn't designed to handle solid calculations. It can't handle user input components like you can put your own chemical components into CHEMCAD. We call them user-defined components, so RefProp's not going to support that. And there are equipment models like three-phase separators that are not going to be able to support RefProp, or RefProp does not support those is a better way of saying it. So those equipment models will not be available when you have the RefProp library activated, and I'll show you how to see that in the CHEMCAD interface in a minute. But I just wanted to let you know that there are some application areas that RefProp does not support, or it's not a good fit. So we did our best to make sure that CHEMCAD is telling you when RefProp's a good fit or when it's not a good fit. So just guiding you and helping you make those decisions a little bit easier. The other thing is in traditional CHEMCAD simulations, yes, you can have local thermodynamics and choose different models for different parts of your process in one simulation file, but when you're using the RefProp library, you cannot create local thermodynamics or hybrid models with the CHEMCAD-REFPROP library. So I've been talking about it enough. Let me go ahead and open CHEMCAD. I'm hoping you are familiar with the CHEMCAD interface. I'm not going to really go into exploring the CHEMCAD interface. So if you're new to CHEMCAD, please check out some of our other training videos available on YouTube. But for now, I'm going to assume you're familiar with the interface and you have this ribbon menu at the top, which looks exactly as it has before for a few years now. And so the difference that you'll notice is here in the thermophysical tab. We have this new section called Library, and that's where you can switch back and forth between the CHEMCAD or the RefProp library. And so for now, we can see that we're currently in the CHEMCAD library, so everything should look as you would expect it, and you don't really notice a difference. Let's try and add some components then. I'm going to start with a a natural gas example, so I'll just add some common natural gas components: methane, ethane, propane. Let's try some butane, and I'll add some pentane as well. I think I pass it up. There it is. Okay, so I have added some natural gas components using the Select Components menu in CHEMCAD as I normally would. And I say OK. And so normally you would get a thermodynamic settings wizard that would guide you towards suggesting what models are great for based on the components that you've selected. And in this case, now that we have REFPROP, it first lets you know that this is a great, based on the components that you have selected, this is a great fit for the REFPROP thermophysical library. So it's asking whether you want to switch from the default CHEMCAD thermophysical library to use REFPROP. And so this is how CHEMCAD is designed to have the CHEMCAD library as the default, and you have to go in and manually switch to REFPROP to get access to the REFPROP library. So for now, I'm going to say no. And so that brings me up to that thermodynamic suggestions wizard that I mentioned a second ago, and this is what you're probably used to seeing when you're starting a new simulation and adding components. So I'm going to say OK. And CHEMCAD has recommended using the SRK or Suave-Redlich-Kwong equation of state as my model based on the components, the natural gas components, and that's been a pretty good fit so far, so I'm going to say OK. And now I want to, let's say, have a separator, a basic flash separator. So I'm just adding feed and product streams for my flash calculation. Great. So now I'm going to go ahead and add a composition. Let me do a low temperature. Let's look at some extreme conditions. Okay, so I'm going to run my flash calculation and check some results. So we see methane is about 31.4, ethane is 11.8, and so that's significant to note when we try and compare this against the REFPROP calculation. So I also like to look at phase envelopes, especially for natural gas simulations, and this just helps visualize the phase behavior of my gas mixture. So I just say OK. And I have this beautiful phase diagram. So I'm going to save this chart as SRK so that we can compare it against REFPROP later. So now we see I've named my chart to identify that this is the SRK prediction. So if I go back to my flow sheet and say go to thermophysical property calculation and now switch from the CHEMCAD library to REFPROP. So now I get this button letting me know, are you sure you want to switch to REFPROP thermophysical library? At this point, I would recommend that you save your simulation because I mean, the simulation values are going to change when you're switching from CHEMCAD to REFPROP. So I'm going to say yes. In this case, I haven't saved my flow sheet, so that's not a great idea normally, but since this is just an example, a quick example, I'm going to go ahead and continue. So now we see this window letting us know that our simulation is currently using the REFPROP thermophysical library. So now we'll see changes in the CHEMCAD menu. So when I say OK, you can see here, I don't know, it happened pretty quickly, so I don't know if you noticed, but some things are grayed out. And so when I was talking about some things that REFPROP does not really support right now, they're going to be grayed out so that users don't try and access things that are not supported with the REFPROP library. So now we are in REFPROP. We can see here library is selected as REFPROP, and now we need to run our simulation again. And we can see here, I don't know if you remember, but methane was, I think, 31, and now it's 27 pounds per hour. So that's going to be a little bit of a different prediction, and that impacts considerations and the designs that we make when we are using REFPROP library versus the CHEMCAD traditional library. The other thing that we can compare is the phase envelope. So I'm going to make a new phase envelope. And this is why I wanted the report printed out in Excel, because we can add this as a user series directly into our CHEMCAD plotting tool. I'm going to say copy, and now I can paste REFPROP into the SRK. Oh wait, hold on. I need to go to the SRK phase envelope first, and now I'm going to be adding my REFPROP calculation. So we've just copied and pasted from our REFPROP calculation into our plot for SRK. So I say OK. And now I'm going to tell it to plot to this chart. So now we can see the dew point and bubble point for the SRK prediction, and then the purple is going to be the REFPROP prediction. And we can see that in some cases they are pretty similar in prediction, but you start seeing deviations in the REFPROP predictions versus the SRK predictions. So that's just something to think about depending on where your simulation lies in the phase envelope, in the operating conditions, or whatever conditions you're trying to simulate. You might be okay with the CHEMCAD library, or you might want to try out the REFPROP library. It's up to you to decide. So this is an example of making a new simulation in CHEMCAD and having CHEMCAD say, hey, REFPROP might be a good fit for this new simulation. But what happens if you have an existing simulation that you've created in a previous version of CHEMCAD and you want to bring it into the newer versions of CHEMCAD which have access to REFPROP, and you want to see how REFPROP is doing for your existing simulations? And you can do that if everything is meeting the right criteria So I'm going to go in and select an example that I know is not supported in the REFPROP, with the REFPROP library. So this biodiesel simulation in our CHEMCAD example files includes some user-defined components, which I mentioned earlier does not fit the criteria required for using the REFRAP library. So if I try and open this, not going to save this. And I was able to open the biodiesel example file. So that's we're saying that this is a file that I've created before. So if I look in thermophysical, we created that with the CHEMCAD library. So it's still under the CHEMCAD library, and you can continue using CHEMCAD as normal. But if I wanted to go in, again, you have to manually change to REFPROP if you want to get access to the REFPROP library. So I'm going to go in and try to access REFPROP, but I'm unable to switch this to REFPROP because, again, there's some user-defined components in here. Some things are not compatible with REFPROP in this existing simulation. So if you have existing simulations and you want to try it out with REFPROP and you see this error message, it's because it's not compatible with the REFPROP library. If it is compatible with the REFPROP library, you'll see that it does switch to the REFPROP library just as it did with that natural gas example that I was just going through. I first created it in CHEMCAD and then switched from the CHEMCAD library to the REFPROP library and allowed me to do that. So that's what you'll see if it is compatible. If it's not compatible, we throw a warning letting you know that it's not compatible, so you can't convert that file to use the REFPROP library. Okay, so that's essentially the basic example that I wanted to show you and how the user interface changed with CHEMCAD. You should have noticed that it looks nearly identical to previous versions of CHEMCAD. We just have the new thermophysical library selection that you can go in and switch back and forth between the CHEMCAD library and the REFPROP library. And again, anytime you add components that are a good fit for REFPROP, it's going to let you know that REFPROP's a good fit as part of that thermodynamic suggestion menu that we usually guide users to which models are a great fit based on the components you've selected. And so now you'll see REFPROP first saying, hey, this is a great fit for REFPROP. You can either accept or deny that recommendation and continue with CHEMCAD or switch over to REFPROP. So up to you to try that out. But I'd now like to go over some other successful applications where REFPROP really shines as the property calculator of choice. And so one of those things is for supercritical CO2. As I mentioned, it's a great choice for fluids that fall under the extremes where some models like equation of state might fall short. So this is like at very low temperatures for cryogenics or very high pressures, in this example, supercritical CO2. So we can go over a plot that shows how properties of supercritical CO2 vary with temperature. And this plot is showing how density of supercritical CO2 varies with pressure. And so this dotted vertical line is the critical pressure. And in this case, we're looking at varying temperatures. So each of these lines is going to be some different temperature, and comparing what the model in CHEMCAD versus the model in REFPROP is predicting. And so this isn't necessarily a limitation of CHEMCAD. It's the model selected in CHEMCAD. So we have that list of thermodynamic models available for property prediction in CHEMCAD versus what the REFPROP calculator is going to be predicting. So just to point that out, that it's the model you're using in CHEMCAD versus the REFPROP model. And so what we're showing here is that at the different temperatures, in some cases you'll have very close predictions between both REFPROP and the model in CHEMCAD versus other times when you have quite different predictions. And in this case, you'll see that REFPROP is matching up very nicely with the experimental data, and there's a more significant difference at some temperatures and pressures versus others. So it's important to consider this, and you might want to run some sensitivity analysis varying temperatures and pressures to determine what is the best fit for your process, because even small deviations in the calculated values can lead to significant errors. And so it's worth it to take a look at the predictions that you're getting so you can make informed decisions. Next, we're going to look at some hydrocarbon applications. Traditionally, people working in oil and gas use equations of state like Peng-Robinson or Suave-Redlich-Kwong, which do well in many cases, but as we do more sophisticated things in these fields like long distance pipelines, and we're working more in high pressures and cold temperatures, liquefaction for LNG, things like that, we need to make sure that we start with accurate phase behavior predictions. So we're finding that REFPROP is an industry favorite for that as well. And if we go over this phase envelope similar to what I was showing you in the CHEMCAD example, this is a natural gas mixture, and these curves are the prediction for the dew and bubble point of this gas mixture. So once again, at the more extreme pressures, you'll see wider differences between the models, between the prediction of the models. But again, in some cases, depending on what your components are, what the mixture is, where your operating conditions are, or what you're trying to simulate, what conditions you're trying to simulate, different models have advantages over other models. So in this case, REFPROP matches experimental data better, especially closer to the critical point compared to the equation of state models. Another thing to consider with natural gas behavior is something called retrograde condensation. This is a phenomenon that occurs for some gases where going from, for example, you'll have single phase gas, and as you reach the dew point part of the curve here, as you're moving down, you'll see your first drops of liquid, and now you enter in having gas and liquid phases. But as you keep moving down, they vaporize again and go back into single phase. So that's kind of counterintuitive, but it occurs, it's a phenomenon that occurs for some natural gases. And so it's not standard behavior, but it's an important behavior to capture for some engineers working in natural gas blends. And so because REFPROP provides very accurate predictions and really captures this behavior, you might want to consider using REFPROP if you're working in some natural gas blends. Of course, as I mentioned, REFPROP was first designed for refrigerant property calculation, so of course it does really well when you're looking at refrigerant fluids. And anyone interested in energy efficiency and working fluids for heat pumps or refrigeration cycles can benefit from accurate refrigerant property calculations. We can look at a formulation example for refrigerant fluids and how studying the refrigerant fluid blends impacts performance and suitability for a process. We can look at this example, which is an R410 blend, and this blend includes R32 and R125, and in the x-axis we're varying the composition of this blend. So ideally, when you're selecting a working fluid, you want it to be environmentally friendly. You also want to increase your coefficient of performance. So these curves are comparing the REFPROP prediction, which is on the top, with the other two equations that were used by customers traditionally in CHEMCAD. You can see how the coefficient of performance changes with the different blend amounts, and its predictions are quite different than what you're seeing with the CHEMCAD library models here. So those are just some examples of good application areas, common application areas for using REFPROP. Those are not the only application areas. Of course, it's just if it fits the criteria for REFPROP, then it's a good idea to check it out and get really accurate property calculation through the REFPROP library. See how that impacts your decision making. So based on everything I've mentioned today, from the history and the criteria that is best suited for REFPROP, as well as demonstrating for you how this looks and how this works in CHEMCAD, the main takeaways that I wanted to share with you today is that there is not a need to install or get a license for REFPROP. This is given access to all users who have access to the latest versions of CHEMCAD. So hopefully you're checking your email and you'll be able to install the latest version of CHEMCAD. You can get access to REFPROP just as I showed you during the demonstration. It's just that single button that allows you to switch your flow sheet between REFPROP and CHEMCAD. Again, the CHEMCAD library is going to be the default always. You have to go in and manually choose REFPROP if you want to switch your simulation to the REFPROP library, the REFPROP fluid property calculations. And the impacts of adding REFPROP are felt beyond just calculating properties. I mean, I shouldn't say just calculating properties, because that is possibly the most important part. The more accuracy you get from your property calculations, the more accuracy you're going to get out of equipment sizing and your steady state or dynamic models. The basis of your calculations are coming from the accuracy of your property calculations. So the effects are felt throughout your CHEMCAD simulation of having access to more accurate property calculations. And of course, the benefit of having access to the REFPROP property calculator is that we also have now expanded use cases. So people who are working with heat pumps or working fluids are going to now have access to not only better accuracy, but the industry standard for calculating refrigerants. Also, industry favorites for natural gases and supercritical fluids. So we have now access to more expanded use cases that can benefit from having RefProp integrated into CHEMCAD. So if you were curious about what you've heard today and you had more questions or you required more help, please do reach out to us directly. We can help answer any questions you may have. This webinar, as well as others that we've done in the past, are recorded and dropped into ChemStation's YouTube channel. And so please check out our YouTube channel. This is the first of our RefProp related content, but we do have more information, help, text, and examples that we can help you get started with. If you have a need for more help, we can also give you some guided demos or like a live demo for your team. So please do reach out to us and we can help you get started with RefProp and answer any questions you might have. And if you are not yet a customer for ChemCAD and you want to get a demo, then again, please do reach out to a sales representative and we can get you an evaluation license to help you get started in ChemCAD testing RefProp for your process simulation needs. So that's all I had to discuss with you today. Hopefully you've been getting the regular email updates. The latest one we've sent out recently also is notifying users about our new ChemCAD support email. That's chemcad-support@datacore.com. If you have not seen these emails that I'm talking about for new versions of ChemCAD or changes to our support email, it means that you need to get in touch with the ChemCAD support and we can help you get resubscribed to these email notifications. And you can, of course, get access to the latest version or submit support tickets as you have in the past through your customer support portal. So please continue to use that, and we're happy to help you get started using ChemCAD and RefProp. Thank you for your time and attention, and have a great day. Thanks.